welcome to True Projects. In this video, we are going to explain about a project titled A Lightweight Vision-Based Measurement for Hand Gesture Information Acquisition. Gesture recognition serves as a versatile means of interacting with the devices or interfaces by utilizing the movements or gestures, which encompass the hand and the body motion, facial expressions, and even vocal directives. In the contemporary landscape, hand gesture recognition stands out a streamlined and rapid approach within the human-computer interaction. Hand gesture as a form of non-verbal communication bear distinctive significance and the implications predominantly combined through the alterations in the palm orientation and the intricate configuration of finger flexicon. In the realm of hand gesture recognition has evolved to become one of the most initiative and efficient modes of engagement. It empowers the users to seamlessly navigate and manipulate the digital environment through the fluid hand and the body movements, eliminating the need for the traditional input mechanisms like keyboard and mice. This translates to enhanced user experience characterized by heightened interactivity and reduced cognitive load. In this innovative approach, an agile vision-based measurement framework tailored for the realm of hand gesture recognition. This adopt system finds utility in not only human-computer interaction setups but also in the realm of sign language interpretation robotics, amplifying the scope of its application. The conventional methodology of devising a distinct model for the disparate dataset harbors its own set of complexities. To surmount this challenge, we introduce a pioneering concept, a hand gesture information acquisition instrument. This mechanism is framed to scrutinize both the external dynamics encompassing the rigid body motion and the intricate microsome of internal hand gesture. This dual-faceted analysis transpires the concurrently signifying a novel stride towards the holistic gesture understanding. And furthermore, we leverage the process of improved Kalman filter to emulate the veracity of predictions in the scenarios involving swiftly moving entities. The integration of Kalman filters serves as a corrective measure countering the potential error induced by high-speed object detection. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel IP, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, we need to import the necessary Python libraries such as NumPy, OpenCV, TensorFlow, Flask, and the relevant libraries. These will be used for the data manipulation, image processing, model loading, and the web interface development. And the second one is exploring the dataset. In this step, dataset exploration involves understanding the structure and the distribution of the pre-existing hand gesture images. This involves a labeling of annotating the data if necessary. And the third step is image processing. From the pre-processing step on the input images, these steps might include of resizing the image, appropriate input size for the model, normalization and the transformations required for optimal model performance. And the next step is loading the pre-trained model. Load the pre-trained YOLO model using the deep learning framework like TensorFlow. This model will be responsible for detecting and localizing the hand gesture in the input images or frames. And the next one is data augmentation. Apply the data augmentation techniques to the dataset to enhance the model generalization. Augmentation includes random rotation, flips, brightness adjustment, and of many more. And the next step is processing the data based on the YOLO v5 model. Utilize the loaded YOLO v5 model to process the pre-processed input data. The model will detect the hand gesture and provide the bounding box prediction for each detected gesture in the image. And the next one is building the model. And this, we are building the various models. The first one is YOLO v5. YOLO v5 is an evolution of YOLO architecture known for its real-time object detection capability. It is designed to efficiently and accurately detect the object including the hand gestures, images, and key features included in this are speed and accuracy trade-off suitable for the real-time application. And the second one is YOLO V8. YOLO V8 could refer to the hypothetical version of YOLO architecture. However, as of my knowledge, a series includes of YOLO V3 as of latest version. It has developed after likely to build upon the strength of its predecessors. And the next one is YOLO X. It is an advanced object detection model that extends the YOLO architecture. It aims to achieve a better balance between the speed and accuracy, improved average precision on the various datasets. And the next one is YOLO V3. YOLO V3 is an earlier version of the YOLO architecture, recognized for its strong real-time object detection capability. While it not be the most recent version, but it provides the good performance in various scenarios, including of the object detection task. And the next step is YOLO V3 Tiny. It is a tiny lightweight variant of YOLO V3 designed for the faster inference on the resource-constrained devices. It sacrifices some accuracy for the improved speed and the reduced model size, making it suitable for the real-time application with limited computational resource. And the next one is faster RCNN. It is a popular two-stage object detection model. It uses a region proposal network to generate the region proposal followed by the region-based convolutional network for the object classification and the localization. And the next one is SSD. It means of single shot multi-box detector as it directly predicts the object bounding box and class probability from the feature map. It strikes a balance between the speed and accuracy and is sustainable for the real-time application. And the next one is RCNN. It's the name of Regional Convolutional Neural Network, laid to foundation for the modern object detection method. It involves the region proposal generation, feature extraction, and the class-specific object detection using the SVM. It's less efficient than of the faster RCNN and YOLO. It contributes significantly to the development of object detection techniques. And the next step is user gives the input as image. Creating a Flash web application that allows the user to upload the image containing the hand gesture for the analysis. And the next step is the given input is pre-processed with a trained model used for the detecting. And here the user input image is during the dataset is pre-processed and utilize the trained YOLO models to detect the hand gesture and the input data, obtained bounding box prediction. And the next one is the segmented each object and put the bounding box. For each detected hand gesture, segmented the object within the bounding box. This involves cropping the region of the interest from the original image, overlay the bounding box on the original image to visually indicate the detected feature. And the last one is final outcome as displayed. To process the image to the user through the Flash web interface, each gesture should be highlighted with its respective bounding box. This user-friendly output provides an easily interpretable representation of the detected hand gesture. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of the various images that will be used for testing the performance of the model, and the static folder containing of the folders like CSS, JavaScript, images, fonts and assets within it, and the template folder containing of the HTML documents like of about, home, index, notebook, sign-in and sign-up pages within it. And the YOLO model folder containing of YOLO model within it, and the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And these are the Python files, and this is a notebook IPNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file that to be appear to be the database file used to store the user information. And these are the training datasets that we used in this project. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command with the cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. After clicking on enter button, app.py files will run and the application will host the address as of like this by using the Flask as a framework. And I'm copying this link and pasting this link on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and here we redirect it to this page containing of the title and some information about it. And then click on the sign up button. Here it will redirect it to the sign in page containing of some details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here I'm entering the details of username and the password as of admin. And then click on the submit button. Here it will redirect it to the sign up page containing of choose file and upload button. And click on the choose file button. Here it will redirect it to this folder containing of various images within it. I'm selecting one of the image from it and then click on the upload button. Here it redirected to this and viewing the bounding box and the indication as of false. And by clicking the back button and the refresh button, here we re-enter the other images by choosing the file button. I'm selecting another image and then click on open button and then click on upload button, and here the bounded box is created and it views as of mute with 0.89. In this way we can detect the hand gesture information by visual images. And in conclusion, the proposed lightweight vision-based measurement system for the hand gesture recognition using the CNN-based object detection model, YOLO V5 structure and the improved Kalman filter can accurately obtain the hand gesture information and improve the recall rate and the average precision metric of the prediction box. It also suggests the future work to analyze and improve the feature extraction process with a better performance.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.